Dear students, welcome you all to the course that is Fabric Manufacturing Technology. In the last session, we have discussed about the limitations of a ordinary loom. Nothing but the limitations of shuttle loom, and along with that we have seen that what is the features of shuttleless looms are. Compared to shuttle loom, what are the advantages or the features of the shuttleless looms are, we have discussed in the last session. So here today we are going to discuss about the classification of shuttleless looms. So what are the different types of shuttleless looms are there? What are their classification we are going to see particularly this session. So before going to the topic, we will see that what are the contents, and today we are going to discuss about the classification of shuttleless weaving machines. So after that we are going to discuss about the projectile weaving technology and the rapier weaving technologies. Okay, so we'll start about that. What are the different types of shuttleless looms are, shuttleless weaving machines. So these particularly shuttleless weaving machines are classified into different categories, like 4 categories. So 4 different types of shuttleless weaving machines are generally used, and one of the shuttleless loom is rapier. There is a rapier loom. So here particularly the rapier looms, nothing but, so we are going to insert the weft yarn. We are going to insert the weft yarn. So by means of a rapier, So nothing but in case of shuttle looms, how the weft yarn is using shuttle looms, we are inserting the weft yarn with the help of shuttle. So there is a shuttle, inside the shuttle there is a pun, there is a weft package. So by using the shuttle, we are inserting the weft yarn from one side of the cloth or from one side of the shed to the other side of the shed. So using a shuttle, we are transferring the weft yarn, or we are inserting the weft yarn from one side to the other side. Okay. Now in case of shuttleless looms, there is no shuttle, there is no use of shuttle. Now we are using some element. There is an element that is called as a rapier. There is a rapier, like my fingers. So there is a rapier. Now the rapier is going to hold the weft yarn and it is going to insert in the shed. Okay. After the insertion, there is a holder. The weft yarn is going to hold at other side, and again the rapier will come back to its original position. Okay. So nothing but there is an element which is going to insert the weft yarn from one side to the other side. So every time, particularly in shuttleless weaving machines, for one time only one peak length is going to be inserted. Nothing but here you are inserting the weft yarn, particularly depends upon the fabric width required. Nothing but only one peak is going to take from one side to the other side. Then again the picking mechanism will come back to its original position. Then again the weft yarn will be holded and it will be going to insert. Okay. Nothing but every time the weft yarn is going to hold and insertion can be done. Then other end there is a holder which holds the weft yarn. Then the element is going to release the weft yarn. Then it comes back to its original position. So this is how in the case of shuttleless weaving machines, how the weft yarn is going to insert. So now there is a rapier head which is going to be inserted. There is a rapier head which is going to insert the weft yarn. Okay. So particularly, so there is an element which is called as the rapier, which holds the weft yarn and it is going to insert the weft yarn. Okay. So this is called as the rapier, and in particular to the rapier weaving machines, we have different types of rapier machines, like a single and double rapiers, single rapier weaving machine and double rapier weaving machines. So we will see that what is the sub-classification of these rapier weaving machines in the rapier session. Okay. And the next shuttleless weaving machine is projectile. So the projectile is the next machine, and in the projectile also we have single projectile and the multiple projectiles. Nowadays most all of the companies, all the bulk production areas, we are going to use the multiple projectiles. So why it is using, we will discuss further slides. So the second machine that is in the shatterless weaving technologies, that is projectile weaving machine. And the third one is called as the fluid jets. Fluid jet. What is the fluid? Fluid jets are nothing but air jet and the water jet. Air jet and water jet. Again, in the air jet we have, whether it is single air jet we are using or multiple air jets we are using, we have classification. Okay. So there are machines like which is having a single air jet nozzle, and there are machines like a multiple air jet nozzles also there. Okay. So that the weft insertion will be done with the help of multiple jet nozzles. Okay. So how it is going to be done, we will discuss what is the picking phases are there in particular to each and every category. Okay. And the second fluid jet is, that is water jet weaving technology. By means of water, we are inserting the weftian. Air jet means by use of air. By means of air, we are transferring the weftian from one side to the other side. Okay. So the fourth one is multiface weaving. In the multiface weaving, we have again subclassification, that is circular multiface weaving and flat type. There are different types. Okay. So this is the simple classification of the shatterless looms. So what are the shatterless looms? Shatterless looms are classified into 4 different categories. One is called as rapier, projectile, fluid jets. In fluid jets we have air jet and water jet weaving and multiface weaving. Okay. So these are the different types of shatterless looms we are using in the shatterless weaving technology. Okay. So now we will look after what is exactly the rapier weaving is. So rapier loom comes in many types. Early models of it is long rapier devices that travels along width of the loom to carry the weft from one side to the other side. So to carry the weftian from one side to the other side, there is an element called as the rapier. So there are 1 rapiers or 2 rapiers, depends upon the machine. So if it is having one rigid rapier, so this is called as a single rapier weaving machines. And if the 2 rapier heads are there, 2 rapiers it is involved to transfer the weftian from one side to the other side, then this case we can say that this is called as the double rapier system. So they may be rigid or they may be flexible or telescopic. So there are subclassifications. So one rapier feeds the weft halfway. So in case of double rapier system, and the second one is going to take from the half of the part. Nothing but if we have one rapier head, so the rapier is going to hold the weftian from one side and it will take up to the other end. Okay. And if we have a double rapier heads, so both will come into the middle, but one rapier will carry the weftian up to the middle. The second one also will come into the middle zone. So from at the middle of the shed, the weftian is going to be transferred from one rapier to the other rapier. Then second rapier will hold the weftian and it will pull the weft thread into the shed. So that the total pick is going to be inserted in the shed. So this is how we are going to insert the weftian, and generally these rapier looms are going to be run at the speeds of like 200 to 400 also it is there nowadays. Nowadays 400 also we can run, and there are like different varieties of fabrics can be made by using these rapier weaving machines. Okay. So like sheddings or multiple dobby sheddings also can be used to produce the small motifs in the fabric. Okay. And as well as you can go for the jacquard shedding also by using the flexible type of rapier weft insertion system. And so there are like additional attachments you can run at the machine at 400, 600 picks per minute, picks per 1 minute. Okay. So this is how the rapier insertion will be done. Okay, so we will see that small videos of all the rapier weaving machines, so that what is exactly the rapier weaving insertion and the projectile weaving insertion and the air jet or fluid jets are, okay, and multi-phase weaving technologies are. So we will see a small video of these all shuttleless weaving machines so that you can understand better. Okay.
In this segment, we describe how filling yarn is actually inserted into the fabric. Several systems are used to insert the filling. These include shuttle, rapier, projectile, air jet, and water jet. The shuttle loom was the first type of power loom developed. It uses a shuttle that is a boat-shaped device that holds a small quill of yarn. The shuttle is the only powered insertion system that carries its own yarn supply across the warp. The maximum speed of these looms varies with the width of the fabric, but most produce between 150 and 200 picks per minute. Rapier filling insertion is one of the most versatile of insertion types. This is due to the rapier head gripping the yarn and carrying it across the width of the shed. Therefore, any yarn, from extremely fine to very coarse, can be woven. Also, very different yarns can be woven from pick to pick without readjusting the rapier. There are 4 types of rapier systems: single rigid, double flexible, and double telescoping rapiers. The single rigid rapier uses a solid rod material that carries the yarn completely across the warp. This loom footprint requires twice the floor space of the rapier due to the fact that when the rapier is not in the shed, it is housed in a sheath external to the shed. Double rigid rapiers use 2 rapiers that are just over 1/2 the width of the warp. Each transfers the yarn halfway across the warp shed. This still takes up the same amount of floor space as a single rigid rapier because each rapier is stored on either side of the loom. However, the speed can be increased because it takes less time to insert a pick, since each rapier has only half the distance to travel in the shed. Double flexible rapiers use a flat metal tape or high-tech composite material to transfer the yarn across the warp shed. The advantage of this system is that the floor space is reduced since the rapier storage space is reduced. Because the rapier is flexible, it is coiled into a circular sheath when not inserting the filling. The rapiers are much lighter, resulting in higher processing speeds. Flexible rapier looms are capable of reaching 850 picks per minute on single-width fabrics. Double telescoping rapiers use sliding or telescoping devices to insert the filling yarn. They're similar to double rigid rapiers, but since they telescope, much of their length is stored inside the rapiers themselves as the rapier collapses, thereby reducing the width of the loom. This type of rapier loom can only achieve a maximum of 350 picks per minute due to the weight of the rapier and the time required to extend and contract it. The projectile filling system uses a small bullet-shaped object to carry the filling yarns across the warp shed. The bullet, or projectile, is similar to the much larger shuttle in shape. However, the projectile does not have a self-contained yarn supply. The projectile must be presented with a yarn which it grips just before it is propelled across the warp shed. A projectile is presented to the picking arm and is fed a yarn. It is then fired across the loom through guide teeth to where it is caught in a braking device. It is then returned to the picking station by way of a conveyor chain. Several projectiles are in use at any time so that rapid pick insertion can occur. Air jet filling insertion uses a stream of high-pressure air to insert the filling yarn into the warp shed. This is the fastest conventional method of weaving. Air jet looms consistently reach production speeds of up to 1,000 to 1,200 picks per minute on single-width fabrics. Air jet looms require very expensive profiled reeds to channel the air and yarn across the shed. Air-jet weaving inserts the filling from an off-loom auxiliary supply system that accumulates the exact amount of yarn needed to travel across the shed. An initial burst of air starts the yarn on its way, and several auxiliary nozzles then help propel the yarn completely across the warp. These auxiliary nozzles are evenly spaced and fit into the tunneled or profiled section of the reed. Water jet filling insertion uses the same concept of filling insertion as the air jet. Water is used instead of air to project the filling yarn across the warp shed. Due to the higher density of the water jet as compared to the air jet, booster nozzles and profiled reeds are not needed. Speeds of water jet insertion rival those of air jet weaving. One shortcoming of water jet weaving is that only hydrophobic fibers can be used. Multiphase insertion is the newest technology for inserting picks into the warp shed. This system uses a series of 4 air jets on a rotary drum to reach a pick insertion rate of up to 2,800 picks per minute on basic plain weaves and twills. Due to its complexity and ability to do only very simple weaves, very few multiphase weaving systems are in use.
So these are some of the videos of shuttleless weaving machines. I think you people have gone through it. Okay, so let us discuss about the projectile. So projectile means, as you have seen already, it's like a small bullet shape of element, so which is going to hold the weft yarn by the help of grippers, and the projectile will send from one side to the other side, like similar to the shuttle weaving. But the picking mechanism and the component or element which is transferring the weft yarn from one side to the other side is different. So the projectile weaving is having a small bullet kind of element which carries the weft yarn, which holds the weft yarn and carries the weft yarn from one side to the other side. Okay. So again, after the insertion, the projectile will come back to its picking position, and again it will be fed the weft yarn. So then the picking will be done. So the projectiles are going to run from one side to the other side, then again it come back to its original position, then again picking will be done. So this is how the picking insertion will be done in case of projectile looms. We will see that what is exactly the picking mechanism, how the pick is going to be inserted. That is nothing but the picking phases, particularly in projectile weaving technology. So along with that, we are going to use a special type of selvage mechanism that is called as a tucking in selvage. So there is a tucking in device where after the insertion, the free ends of the weft threads, both the sides of the selvage is going to be tucked in, nothing but it is going to fold it into the next shed, so that the free ends or the fringe of the weft yarns are not visible. So now it is going to fold the weft yarn, the edges of the weft yarn is going to be folded into the new shed after the new shed opening, so that it will be going to interlace again. So you are going to get the closed type of selvage at the ends. Okay, so this is the particularly like a selvage mechanism we are using in case of projectile looms. Okay, and these looms need smooth and uniform yarn which is properly sized in order to reduce the friction. So the projectile looms can produce up to 300 picks per minute. So even we can go for up to 400 picks per minute also. So getting very less noise, and then compared to the shuttle looms. Okay, this is how the projectile loom is. And the next one is called as air jet weaving. So in the air jet weaving, so there is a jet of air is used to propel the weft yarn or hold the weft yarn and transfer the weft yarn through the shed from one side to the other side. So we can run the air jet looms at generally like 700 picks per minute, 800 picks per minute. And nowadays there are machines which are developed by one of the manufacturer, like 1400 picks per minute. Okay, 1400 picks per minute also can be done in case of air jet looms. So this is how the air jet looms are. So by using the air, we are going to hold the weft yarn and we are going to transfer the weft yarn from one side to the other side of the shed. Okay. So the pick insertion will be done by means of air, stream. Okay. So also heavier yarns are suitable for air jet looms as the lighter fabric are very difficult to control through the shed. So heavier fabrics are generally like 40s count, 30s count, okay, 30 CNE, 40 CNE, 50 CNE can be used in case of air jet looms. Okay, too finer yarns are somehow difficult or somehow it will be going to have some problems in the case of finer yarns to carry the weft yarn or to control the weft yarn insertion in the shed by means of air. Okay, so however, too heavy yarns also cannot be carried out, like so very coarser counts also cannot be carried out because the consumption of air, the force required to transfer the weft yarn or pull the weft yarn from one side to the other side is going to become complicated. So that is why too heavier yarns also not possible. Okay, so this is about the air jet, and we have a water jet. Water jet nothing but we are going to insert the weft yarn with the help of water jet of water. So we are going to create the pressure in the water by using the picking mechanism like a piston type of pumping mechanism where the yarn, where the particularly the water is going to be created or pressurized. Okay, then the pressurized water is going to be transferred through the orifice of the nozzle, and by means of the water droplets or water pressure, it holds the weft yarn and it will transfer the weft yarn from one side to the other side. Okay, so it carries the weft thread and it will pull the weft thread throughout the shed. Okay, so generally these water jet looms are going to be preferred to produce the synthetic yarns or man-made fibers. So because if you use the cotton, what will happen? It will absorb the moisture or it absorbs the water content, and the pick, whatever the weft yarn is there, it becomes heavier. So you require more force to transfer the weft yarn, or it requires more force to pull the weft thread in the shed, as well as after the picking insertion also, if you apply the more force and if you are increased force to pull the thread, and if you have done the fabric also, again you required an additional mechanism to dry the cloth again. So that is why generally it is not preferable for absorbent threads or absorbent yarns where particularly cotton, viscose fibers are. And in case of filament yarns like nylon, polyester, it will not absorb the water content or moisture. So the pick weight will not be, mass of the pick will not be increased after application of the water, and it will not absorb the water. So there is no that much of drying is necessary for the particularly like in case of filament yarns. So that is why it is specifically it is used for the filament yarn or filament fabric production, particularly like filter fabrics and few industrial fabrics also can be manufactured by using the water jet weaving technology. Okay, so this is the related to the shuttleless weaving technology, and particularly we have another mechanism or another type of shuttleless weaving machine, that is multiface weaving technology. So generally now in case of shuttle looms and in case of shuttleless looms, whatever we have discussed, shuttleless looms up to projectile, rapier, air jet and water jet. At a time, how many number of sheds we are farming? We are farming at a time only one shed. We are farming at a time only one shed. So only one shed we are farming and we are inserting only one weft yarn. But in case of multiface weaving technology, we are creating multiple sheds at a time. We are creating multiple sheds at a time. So that is up to 4 number of sheds can be formed in case of multiface weaving simultaneously. I am telling simultaneously, nothing but at a time 4 sheds will be formed in different places. 4 picks will be inserted simultaneously. So you have to remember that 4 sheds are going to be formed at a time in case of multiface weaving. 4 picks will be inserted at a time. So what is the production rate compared to rapier or air jet or projectile? It is 4 times greater than the higher production or more production than the normal shattleless looms. Okay. So in shattleless looms, that to air jet or rapier, we are inserting only 1 pick per 1 shed opening. So we are here multiface weaving, we can produce 4 different sheds at a time. 4 picks will be inserted at a time. So 4 times production will be more. Okay. So that is the thing. And we have another model, that is the circular looms also. So in particular to circular looms, we are going to, you can see that one of the application is like our sack bags. Sack bags nothing but your rice bags, cement bags, the onion bags. Okay. So whatever the polypropylene bags are there presently, sugar bags, urea bags, all are. So all these kind of flat yarns or flat yarns they are using to produce the circular fabrics. Okay. So there is a circular loom. So it is going to create the shades in circular manner, and there are shuttles which are going to insert the weft yarn in circular fashion. Okay. So that is the thing I have given. These looms are particularly used for making tubular fabrics rather than the flat fabrics. Okay. Tubular fabrics, nothing but the sack bags, it is tubular. Okay. So a shuttle device in it circulates the weft yarn in the shed formed around the machine. So there is a machine. So throughout around the machine, so there are sheds formation. In the sheds there are shuttles. So shuttles are going to insert the weft yarn around the circumference of the machine, around the shed formation. Okay. So this is how the circular looms are there. Okay. So these are the introductory thing where the classification of particularly shattleless looms are. So we are going to discuss about each and every shattleless loom. Okay, from now onwards. Okay. So this is up to the classification of shattleless looms. So in the next session we will start the first machine in the shattleless looms, that is projectile weaving technology. Projectile weaving technology. So we are going to start that. What are the shattleless looms? What are the picking mechanisms? What is the picking phases? What are the elements in the weaving machines particular to projectile weaving, rapier weaving, air jet, water jet, multiface weaving technologies are. Okay. So till the next class, thanks for listening. Bye.